Everyone, my name is Darrell. I'm a technical sales representative with Mica Corporation. During this presentation titled Adhesion Made Compostable, I'll be presenting to you some of the challenges associated with developing compostable packaging. I'll also present some of the technology advancements that can make compostable packaging possible. Just brief information about myself. I've been in the industry for a very long time. The last 15 plus years I've been in a technical sales or technical service role. I've been with Mica Corporation since 2014. And most recently, I've worked with our product development group in the development of a new compostable adhesion promoter specifically designed for hot cup applications. Now, these are the topics we'll be discussing today. We'll talk about sustainability in the packaging industry and some of the initiatives that are in place. We'll talk about the long road to compostability and some of the challenges we face. We'll talk about paper-based packaging as a potential solution. And then we'll talk in specifics about the new compostable adhesion promoter product, along with some of the potential applications that could also benefit from these applications. Sustainable for the packaging industry. There are leading brand owners, retailers, and packaging companies have initiatives in place with goals of achieving 100% reusable, recyclable, and compostable packaging by 2025. These are commonly referred to as the 2025 initiatives. Converters and packaging producers are exploring new technologies that will help create sustainable and or recyclable packaging structures that consumers and brand owners are demanding. The demands for new technology have guided Mica's efforts to develop a compostable adhesion promoter product. Now, achieving sustainability in the packaging industry will likely take a multi-pronged approach. For example, recycling may be a great option for densely populated areas, but may not be viable for rural areas. Because there's no one-size-fits-all solution to sustainability, it's important for packaging converters to tackle the problem from all angles. One approach that has gained traction in recent years is the development of 100% compostable packaging. Now, the demand for compostable solutions keeps growing, and there's a reason why. There are many benefits associated with compostable packaging. So compostable packaging materials break down completely in the earth, leaving behind no waste or harmful residue. In most cases, compostable materials can help condition the soil in which they degrade. In essence, make it better. So materials that are composted properly do not end up in landfills and or the environment. The lack of compostable packages in consumables is not due to lack of effort from the packaging industry. It's been difficult for packaging manufacturers to develop viable compostable packages for consumable products for several reasons. First, the industry standard for consumable packaging has been a moving target. For many years, marketing terms pertaining to environmentally friendly products were not regulated. Prior to the release of the FTC Green Guides in 1992, environmental marketing claims like compostable on packages were not clearly defined or enforced. During this time, it was impossible to tell if a package would safely degrade in a compost environment. Even after the FTC published the Green Guides in 1992 to define terms like compostable and recyclable, there was still a lack of testing standards to back up these claims. So in 1999, the ASTM D6400 was instituted and used to determine if a package would degrade safely in a compost environment. It's still the most widely used and trusted standard in the compostability today. So let's talk a little bit more detail about the specifics of the D6400 standard. So many companies in the industry are choosing to obtain compostable product certification from BPI, or the Biodegradable Products Institute. BPI is North America's leading certifier of compostable products and packaging. In order to claim a package is certified compostable, the finished structure must pass BPI's rigorous tests, which includes the ASTM D6400 standards. The specifics to some of the tests that are involved in the D6400 standard are chemical characteristics, disintegration, biodegradation, and ecotoxicity testing. Let's talk a bit in more specifics about these categories. The chemical characteristics testing is mainly to find if there's any kind of harmful byproduct of the degradation process. So it's looking for any kind of heavy metals or any other kind of harmful component that would contaminate the compost stream. The disintegration testing is making sure the product breaks down to a small enough particle size. So the standard reads less than 10% of the particles remaining are greater than 2 millimeters in size. So then we go to biodegradation testing, and the standard reach for this is 90% of the material must biodegrade within a 6-month time period. So there is a time limit on this process. And this is all based off of CO2 off-gassing. So it's a measure of CO2 is a byproduct of the degradation process, and they can equate the amount of CO2 being off-gassed to the amount of degradation that's taking place. They also, the ecotoxicity testing is really just make sure there's no harmful effect on plant growth. Now, as you can guess, getting a product certified compostable is a long and expensive process. As I mentioned, it can take up to 6 months to complete. Many converters look for compostable components and technologies in every step of the packaging supply chain. Using all compostable components can help converters avoid delays and drastically reduce the possibility of failing the compostability testing. With new net technological advancements across the packaging supply chain, including compostable adhesion promoters, the creation of compostable multi-layer packages is now possible. Many packaging professionals have chosen to use paper substrates to create compostable packages. So paper-based packaging has many sustainability benefits as well as some limitations. Just a few of the benefits of paper-based packaging. On the environmental side, is made from wood, so it's a sustainable and renewable resource. The Forestry Service has done a great job as making it a renewable resource and replanting forests and rebuilding forests to be efficient and environmentally friendly. So, and then the paper is inherently biodegradable and compostable. In many cases, it can be recycled or repulped on its own. There are limitations to this. We'll talk about a bit later. Now, it's also a versatile product, and paperboard substrates work well with rigid applications. So, some of the typical rigid applications that go into are paper cups, gable-top cartons, and or folding carton. There's also thinner substrates, paper substrates that are suitable for flexible applications. A good example of this would be an oatmeal pouch that are individually portioned oatmeal pouches. But there are limitations to paper-based packaging. One being that it's naturally porous, so there's really no barrier properties. So containment can be an issue. If you pour any kind of liquid into a pure paper package, it's not going to contain that liquid very well. It's generally going to leak through or wick through the paper itself. And then it has short shelf life, so there's no barrier properties. So the contents of that package would tend to spoil over time and shorten that time. So paper substrates are also not heat sealable on their own. So if just straight paper, it'd be hard to make a package out of it that could contain any kind of food product. So it's going to be heat sealed polymers or adhesives are going to be required in order to form that package. And in most cases, these type of components are not considered compostable. Let's take a look at paper cups, for example. There are two basic types of paper cup, cold cup and hot cup. We're just going to, just for information, just kind of review the specifics of each. So low density cold cup are low density coated on both sides, both inside and outside of the paper cup. The reason it's coated on the outside for a cold cup and not for a hot cup is in the cold cup, you must protect from condensation. So the contents of a cold cup are generally some kind of iced beverage. So any kind of humidity in the air or in the environment is going to cause condensation on the outside of that cup. So in order to protect that cup and the integrity of the cup itself, it is polycoated on the outside to prevent the paper from softening. So with polycoating on inside and out, you're having a poly to poly heat seal, which means there are no sealing or forming issues. They run very well on the cup making machines. So no adhesion promoter is really required for these applications. Now the hot cup application is very different. It's only poly-coated on the inside. So and there's a reason for this is the poly-coating on the inside is cooler to the touch. So if you have a hot contents in it, if you've ever put hot coffee into a cold cup, you'll realize that poly-coating on the outside really transfers heat very quickly. So having no poly-coating on the outside makes it a little cooler to the touch. There's also less cost because there's less low density. There's only coating on one side, so there's a lower cost associated with hot cup. Now, there's some negatives around this. The less low density polyethylene means it's more difficult to seal because you're trying to seal a poly-coated coating to an uncoated paper itself. And these are thick substrates, so getting heat to transfer through and actually heat seal is difficult. This is where adhesion promoters are used to enhance the heat sealing and forming performance. Now, this is just a little bit about paper hot cups in general, and some of the defects you'll see is we're talking about flaggers. Flaggers is a defect that you'll see whenever the cup machine is outrunning the performance capabilities of the cup stock itself. So on a poly one side, like a hot cup, you'll see there's a bottom stock at the bottom is round, and then there's generally a sidewall stock with a sidewall seam. Now that seam goes up all the way up to the rim of the cup. Now the formation of the cup lip is the most important step in the cup making process. It typically takes 3 to 4 stations in the cup making machine to properly form that rim. Now, where that area of where the sidewall seam meets that rim is the area where you see the flagger defects. You can see the photos on the side. There's one on top is a properly formed rim, and then what we call the flagger is in the photo on the bottom. These flaggers occur. And if they occur more than twice per 1,000 cups made, that can be considered substandard, and the entire batch of cups needs to be tossed. So this is getting good adhesion and preventing these flaggers is the primary reason why adhesion promoters are used on the uncoated side of a paper hot cup. Now, here's some of the factors that are causing an increase in flagger generation. Is the increased cup production demands. New cup making machines can create up to 300 cups per minute. Now, 15 years ago, 150 cups per minute was kind of typical, but now these newer cup machines are running much faster. If you do the math on that 300 cups per minute, that ends up making 5 cups per second. That means the dwell time in each of those forming stations in that cup machine is 1/5 of a second. So you're going through very thick substrates, these heavy paper boards, and you don't have poly on the outside of the paper board. So this is where the adhesion promoters really can add value to the process. Any increase in sealing or forming performance can significantly improve the production rates and the consistency of the product coming off the cup making machine. Now, this is your typical hot cup structure. It is generally a bleached white paper board, usually fairly heavy gauge. It has a poly coating on the inside and a very thin coating of a primer or adhesion promoter on the outside. Typically for low density hot cups, this is a PEI based adhesion promoter. So that adhesion promoter just provides enough additional performance to improve the heat seal performance to allow it to run more efficiently on the cup making machines. Now, there are still environmental concerns around hot cups. So standard low density polyethylene extrusion coating hot cups are not recyclable or compostable. So, and it really can't be recycled either because it's really difficult to separate the poly coating or the adhesion promoter from the paper board, so the paper can be recycled. So this is why the advent of a compostable hot cup would be preferred. Now, there are more than 105 million disposable hot cups used in the United States every day. Many of these end up in landfills or in our environment as litter or pollution. This number is going up every year. It's the amount of disposable hot cups used is growing by 3.6% every year. Now, this is a huge problem. You see that's a big reason why the demand for compostable food service packaging, like hot cups, is expected to compound annual growth of 5% over the next 10 years. Now, to address some of these concerns around environmental issues, cup makers are developing compostable hot cups made from extruded polylactic acid, or PLA, instead of low-density polyethylene. Now, the reason for this is PLA is derived from corn, which is a sustainable resource, so it's not petroleum-based like low-density is. And also, PLA is inherently compostable on its own because it's bio-based. It will compost in a compostable environment. But switching to PLA doesn't completely solve the problem because adhesion is still needed to achieve performance requirements for hot cups. So typical adhesion promoters made from PI are not inherently compostable, and up until recently, viable options were not available. That is until the introduction of our new compostable adhesion promoter product. We think this could be a game changer for the industry. Compostable adhesion promoters can offer a variety of benefits and can assist with the creation of 100% compostable packaging while maintaining the quality consumers have come to expect. So when choosing a compostable adhesion promoter, it should have the following qualities. It must completely biodegrade in municipal and industrial compostable facilities. So the size of this environmental problem with hot cups is huge. So you can't solve this problem by composting in your backyard. This is going to have to be an industrial size solution. So it must. In order to make sure it composts in an industrial environment, it should pass the ASME 6400 standard as a standalone product. It also must promote adhesion of paper to the bio-based materials like PLA and PHA. So if it doesn't perform, it doesn't matter that it's compostable. It really needs to perform well on the cup making machines. And it also must, replace typical adhesion promoters with only minimal equipment adjustments. So no new capital expenditures need to be required. It should be a drop-in for the replacement of the standard PEI adhesion promoters. It must have proper regulatory compliance also for the specified for the application. So then that being hot cup, and it should be a cost-effective solution also. Now, Mica Corporation has recently introduced the solution that provides all the qualities mentioned in the last slide. At 30% solids, Mica MC-634 has a much higher solids level than typical adhesion promoter. Therefore, it would be considered a concentrate. In most applications, the Mica MC-634 would be diluted on site to meet the application equipment demands, make sure that you fit the equipment itself. So if you can see, the Mica MC-634, some of its characteristics are proprietary aqueous emulsion, so there's no solvents. This is all aqueous based. It's a milky white and dries clear. And what's really beneficial is it does not yellow. So this material, being it's going on a white cup, it needs to maintain its color so it will not yellow the cup. So it keeps a good appearance. And again, being 30% solids, it is on the higher side of the solids concentration. Now, this is where the rubber meets the road. This is where you can see the benefits of adding adhesion promoters, either PEI-based adhesion promoters or the compostable adhesion promoter. You can see I have three different samples that we tested. One is the blue line is these are all PLA extrusion coated paperboard on one side. On the other side, the uncoated side, the blue line, there is no adhesion promoter added. And the orange line, is Mica 8788 is a PEI-based adhesion promoter. And the Mica MC-634 compostable is the green line. So these are all PLA coated samples. So this is a good comparison for the compostable PLA hot cup application. So as you can see, the heat seal initiation temperature for the no adhesion promoter sample, you can see there's no bump there's really no adhesion taking place at all at 250 degrees F. So they would have to slow the cup machine down in order to make this work properly. Now, the the H788 product, you can see there's a increase in the heat seal initiation at 250 degrees F. And then when you look at the MC-634, there's even more heat seal initiation. So this just shows the benefits of adding the adhesion promoters to the process to improve the cup making performance as far as rate of cups made along with quality. Now let's discuss some of the other potential applications that should benefit from the use of compostable adhesion promoters. The potential is, and these are all need to be tested, but it could be a standalone heat seal coating. We've actually seen, done some work with this in the past. So it has the potential to work both with paper and with bio-based substrates. So it can be applied using standard aqueous coating equipment. So you wouldn't have to have an extrusion coating line. It could be done with standard application equipment. And using MC-634 as a heat seal coating may require a little heavier coat weight than those that are used in the hot cup application. Just the more poly that's there, the more coating that's there, the better your heat seal performance. Another potential application is improving adhesion to extruded PLA resin. So this has a lot of potential because when you talk about PLA, extrusion coating PLA, in general, the bond of PLA to cup stock or to the paperboard is less than it is for low density polyethylene. It's just the chemistry of the two polymers are different. There's a certain amount of oxidation that takes place with low density polyethylene that does not take place with PLA. So that there's no chemical bond involved with that. So whereas low density polyethylene does oxidize, and there's some chemical bond along with mechanical bond that takes place. So extruded PLA generally requires about 20 pounds per ream coat weight in order to achieve a good adhesion. So this is very heavy and it's very expensive. So if you could apply an adhesion promoter as a pre-primer before you extrude PLA on top of it, and it improves adhesion, the potential is that you could actually reduce the actual coat weight of the PLA required and still get good adhesion. This would dramatically reduce the cost of the extruded PLA and the PLA hot cup itself. So, and also using the adhesion promoter, if it does improve adhesion, and which we think it will, it actually could help increase line speeds, because if you get good adhesion, sometimes you have to slow the line down to improve adhesion with PLA. And if you could improve adhesion and then it allows you to speed your line up, then your efficiency numbers go up and your production rates go up. So that, again, reduces the cost of the PLA hot cup itself. Now, in summary, compostable adhesion promoters can provide a variety of benefits in multi-layered paper-based and bio-based applications. And with advancements in new materials and technologies, creating multi-layer compostable packages is now possible. I want to thank you very much for attending. I'd be glad to answer any questions or and discuss any topics with you in the future. I want to thank you for attending again, and you have a great day.